I am Dr. Rajesh Kumar. Today we start machine learning course, and the machine learning course has divided into mainly two parts. One is supervised learning and the unsupervised learning. Supervised learning divided into the mainly two parts. One is classification and the regression. And unsupervised learning divided into the two parts. One is the clustering and the dimension reduction. So let's start on the whiteboard. So we start on the whiteboard. Let's start on the machine learning.
We'll uncover each one of them and what all types they have. Number one, supervised learning. It involves a series of functions that maps an input to an output based on a series of example input-output pairs. For example, if we have a data set of two variables, one being age, which is the input, another being the shoe size as output, we could implement a supervised learning model to predict the shoe size of a person based on their age. Further, with supervised learning, there are two subcategories. One is regression and other is classification. In regression model, we find a target value based on independent predictors. That means you can use this to find relationship between a dependent variable and an independent. Some of the most common types of regression model include number one, linear regression, which is simply finding a line that fits the data. Its extensions include multiple linear regression, that is finding a plane of best fit, and polynomial regression, that is finding a curve for best fit variable. In regression models, the output is continuous. Next one, decision tree. It looks something like this, where each square above is called a node, and the more nodes you have, the more accurate your decision tree will be in general. Next, and the third type, random forest. These are assembled learning techniques that builds off over decision trees and involve creating multiple decision trees using bootstrap data sets of original data and randomly selecting a subset of variables. At each step of the decision, the model then selects the mode of all the predictions of each decision trees, and by relying on the majority wins model, it reduces the risk of error from individual tree. Next, neural network tree. It is quite popular and is a multi-layered model inspired by human mind. Like the neurons in our brain, the circle represents a node. The blue circle represents an input layer. The black circle represents a hidden layer, and the green circle represents the output layer. Each node in the hidden layer represents a function that input goes to, ultimately leading to the output in the green circle's next classification. So with regression types being over, now let's jump to classification. So in classification, the output is discrete. Some of the most common types of classification models include first, logistic regression, which is similar to linear regression, but is used to model the probability of a finite number of outcomes, typically 2next support vector machine. It is a supervised classification technique that carries an objective to find a hyperlane in n-dimensional space.
And data points, their distance c dimensionally correct.
Next, now base. It is a classifier which acts as a probabilistic machine learning model used for classification. So the classifier is based on the Pasty theorem. Coming up next are decision trees, random forests, and neural networks. These models follow the same logic as previously explained. The only difference here is that the output is discrete rather than continuous. Now next, let's jump over to unsupervised learning. Unlike supervised learning, unsupervised learning is used to draw inferences and find patterns from input data without references to the label 2. Main methods used in supervised learning include clustering and dimensionality reduction. Clustering involves grouping of data points. It is frequently used for customer segmentation, fraud detection, and document classification. Common clustering techniques include k-means clustering. Hierarchical clustering means have clustering and density-based clustering, while each technique has different methods in finding clusters. Most dimensionality reduction techniques can be categorized as either feature elimination or feature extraction. A popular method of dimensionality reduction is called principal component analysis, or PCA. Obviously, there is a ton of complexity if we dive into any particular model to help you with each.